Okay, sorry for the mix-up again. We're starting the recording all over. So I indicated that today we are going to be looking at sterilization of media and equipment. And the goal of that is to ensure that microorganisms, which we already affirmed as ubiquitous, were not contaminating our proceedings, maybe cultural proceedings in the laboratory, maybe clinical proceedings in the hospital with the patient. We want to get rid of microorganisms which have been confirmed to be agents of contamination, agents of infections, and agents of decay. So we're saying that if we culture in a very septic manner in the laboratory, we are going to contaminate the media, contaminate the specimen, and we might be reporting presence of organisms which was not initially present in our samples. So we need to ensure that this is taken care of by maintaining proper aseptic technique. We need to also ensure that we don't contaminate and subsequently infect a patient in the hospital who is under our care. Thou shalt not harm the patient, or thou shalt do the patient no harm, as Florence Nightingale said. We want to ensure that the results we're reporting are pathogens. The pathogens we are confirming to be present in our specimen are pathogens that were initially present in specimen, not what we introduce. During practicals, we'll demonstrate some of the ubiquitous nature of microorganisms by allowing you to talk over media, allowing you to cross over media, allowing you to comb your hair over media, and we culture, and you'll be shocked with the millions of bacteria that will be growing. And most of these bacteria, which usually exist as a microbial flora, when they find themselves in a very susceptible environment, a susceptible host, they're usually going to manifest their pathogenicity. And you might find a patient, even dying of a situation that was not initially reported. So we don't want to be the cause of the patient's morbidity. We don't want to prolong the suffering of the patient. We don't want to add to the cost of the patient. We don't want to be responsible for someone dying because of our proceedings. Therefore, this class becomes of essence because we need to get rid of unwanted organisms in our samples, in our experiments, so that our results are reported with a lot of confidence. We must note that it's a very difficult practice. It's a very difficult practice to obtain with 100% assurance, because as we're going to be seeing, some of them are resistant to some of the disinfectants or sterilization methods that we already know that we have in place, especially if not properly implemented. So in the course of this lecture, I always highlight which is best and when, and what is the maximum that method can offer as far as sterilization is concerned. But first, let's look at some terms associated with sterilization and disinfection in microbiology. The most famous one, which I always want to start with, is aseptic techniques. Aseptic techniques, as you'll be hearing me echo over and over in the laboratory, is a set of procedures that you have in place to prevent contamination of sample. A set of procedures you have in place to prevent contamination of samples. So we want to make sure that before we inoculate our media is sterilized, our hands are disinfected, our environment is decontaminated, and the atmospheric surrounding is also discontaminated. We want to ensure that before we touch a patient, our hands are disinfected. We are properly putting on gloves if we are going to get access to fluids from the patient. The environment is discontaminated. And every other material that we are using, whether in the laboratory or in the hospital, is sterile. There's some historical background to this. Prior to the introduction of aseptic techniques, nosocomial infections, commonly called hospital-acquired infections, were reported in about 10% of surgical cases, while delivery cases had more than 25% of the mothers dying of infection. Of course, I'm sure you had an idea of what the delivery procedure is like. You see that if your hands are not disinfected, if the environment is not sterilized, and the very difficult thing to go through, and you can end up either contaminating and infecting the mother or the baby. So aseptic techniques, take note about it and have it in your mind, especially the microbiologist. It is more synonymous to hygiene. Okay, hygiene is when we talk of the general life, I mean, a clean and repeatable life, but is it mean we are restricting ourselves to medical proceedings, either in the laboratory or in the hospital, but I compare it with hygiene, which you are more familiar with, so that you have an idea of what I'm referring to. How do we attain this? How do we attain this? We can get either by sterilization. This is the most effective method to get rid of microorganisms, the most effective. So whenever we talk of sterilization, we are referring to complete killing of all forms of life, complete killing of all forms of life. And of course, this will include bacteria and their spores, and even resistant spores. Now, I said this is the optimum and attain complete killing of the organisms. But then, why don't we always use it? Why don't we always sterilize everything, since it gives us 100% decontamination, which is what we wanted to do in the first place? We'll see that there are setbacks. For instance, the equipment we want to sterilize might not be able to withstand the sterilization procedure. Or take, for instance, your hands. There is no way I can attain 100% sterilization of your hands, because there's no method that can attain that. But for equipment, if we want to get rid of the equipment, it is easier. But if we cannot get rid of equipment, most sterilization methods are harsh on equipment and end up destroying these equipments. So if we want to reuse the equipment, you see that we'll start playing down the type of method we use. And this method now will also play down on the effectiveness of the sterilization intentions. So I'll be highlighting all of this in the course of the lecture. Then we have disinfection. By disinfection, we mean to remove all harmful vegetative organisms. Take note, in sterilization, we said we attempt killing of organisms and spores. But in disinfection, we attempt killing of organisms, but not the spores. So these spores are always going to be there. The spores are going to be present, and there's something that can completely get rid of the spores. That if our intention is to completely destroy the spores, we might start considering what? Sterilization and not disinfection. Now, is antiseptic. An antiseptic is another type of disinfectant, But the difference is that it can be used safely on animate objects. So what I apply on my skin is an antiseptic. An antiseptic will kill an organism on my skin, but not destroy. Disinfection, on the other hand, is more inanimate objects. So these are objects that we want to comfortably kill everything that is present there, except the object. So we could use harsh chemicals. We could even use radiation and so on. Since we every non-living thing that is present want it destroyed using our systems. But with antiseptic, we want to preserve some living things. We can't destroy all living things because if it is on your skin, apply a disinfectant on your skin, it will destroy the vegetative bacteria and also destroy your skin. So those are things that we need to take note of when applying this. We are still on what's related to this, and the next set of words we have sepsis. Sepsis is the opposite of asepsis. So when we have decay as a result of contamination, we are talking of. And when we get rid of contamination, we are referring to a sepsis. So when we prevent decay by preventing contamination, we are referring to sepsis. And therefore, that's where the word aseptic techniques comes in. The set of procedures that you have put in place to ensure the absence of significant contamination. At length earlier. So the type of agents that we attained sterilization, disinfection, or asepsis are classified based on a broad spectrum of activity. Some of these agents can kill the organism. Some of these agents can kill the organism. In this case, they are called bactericidal. The organism was a bacteria. They are called bactericidal if the organism was a bacteria, fungicidal if the organism was a fungi, and so on. While agents that can only inhibit the growth of the bacteria but does not kill it are called bacteriostatic. We can either classify them as a bacteriostatic agent that can only inhibit the growth of the bacteria and doesn't kill it. We can classify it as a bacteriostatic agent, sorry, a bactericidal agent, if it can completely kill the bacteria. Of course, our intentions are to completely kill the bacteria. We have no reason nurturing them for some time. But you see that it might be difficult, as I already started mentioning, to always attain 100% sterilization. So we now have to create off balances to be able to move on. We classify the different types of sterilization methods based on their action. So we can either have a physical agent, a chemical agent, or mechanical removal methods. So I said we are classifying based on their mode of action. It can either be a physical agent, a chemical agent, or mechanical remover. I'm going to go through all these three in greater detail. A physical agent can either act by heat or by radiation. For heating, a physical agent can act by dry heat. And there are two broad methods that we use for dry heating. We can either incinerate or we use a dry oven. A physical agent can either act by moist heat. And here we can use steam under pressure. This will attain sterilization. We can use boiling or pasteurization. There are other methods that I'll be talking about mentioning. So I can indicate here that boiling and pasteurization only attain disinfection, meaning that it will kill vegetative cells, but it will not kill the spores. Physical agents can act by radiation. There are two types of radiations, ionizing radiation and non-ionizing radiation. Ionizing radiation could be through X-ray, gamma ray, and other radiations, cosmic radiations. And most ionizing radiations will attain sterilization. A non-ionizing radiation, the commonly used one is UV. And UV, unfortunately, can usually be destroyed by vegetative cells and not the spores. For chemical agents, we can either have them in liquid form or in gaseous form. For gaseous, we can either attain sterilization or disinfection depending on which agent we are using. For liquids, we can either apply the liquids on animate objects, that is on living tissue, like on your body. And I already mentioned antiseptics already. For instance, when you apply alcohol on your body, when you apply iodine on your body to disinfect a wound, that is called an antiseptic. We can also use chemotherapy, that is drugs, antibiotics, and certain to kill the organisms. I will not be talking on chemotherapy in the course of this lecture because it's dedicated for another session. But I can also note that we can also apply liquid substances on inanimate objects, meaning that we want to kill every living system there indiscriminately. And if we apply a more stronger agent, we can attain sterilization. And if it's a less stronger agent like alcohol, we can only attain disinfection. The last method of sterilization is by mechanical removal. By this, we can either go through filtration, and we can have filtration for air, and we can have filtration for liquids. Air filtration usually results in disinfection. Liquid filtration in some cases may get or attain sterilization. Let's go now into the methods in greater detail. The first one is the physical removal method. And we are using hot air. Remember, physical removal method, we had hot air and moist air. So the first method under hot air we're going to use is what we call a hot air oven. I have here a picture of a hot air oven. It looks like a small refrigerator for those who usually have these small refrigerators in their rooms. The arrangement and packaging of a hot air oven is typically like that of a small refrigerator. As you can see here, these are trees lining meant. The refrigerator, the hot air oven, could be made to function at temperatures of 50 degrees or temperatures as high as 300 degrees Celsius. So temperatures of 50 degrees is usually used to dry objects. So if you've maybe recently autoclaved glasswares and media, and especially glasswares, and you want to dry them before you move to inoculation and other processing, you might want to dry them off. So to do it aseptically is preferable. Use a hot air oven. But if you want to attain sterilization using a hot air oven, then you have to get to temperatures as high as 250 degrees or even 300 degrees Celsius. Of course, the holding time too is very important. You could drop the temperature to 160 degrees and hold it for 1 hour. Now, what is the difference here? The objects might not be able to stand temperatures of 300 degrees, and therefore a temperature of 160 gives us a better option of sterilizing that object, but at a longer time duration. I will not be talking in greater detail about the instrumentation because it's not part of this course. I just wanted you to have a broader idea of what it looks like. Now, when do we use a hot air oven? We want to sterilize hardwares or glasswares. So forceps that we use in the hospital or in the laboratory, scissors used for handling, scalpels and swabs can be comfortably sterilized using hot air oven at even 160 degrees or 1 hour. Pharmaceutical products like liquid paraffin and others can be sterilized, can be disinfected at 50 degrees or a little higher temperatures, but not too high because most of them cannot withstand high temperatures. The next method under hot air sterilization is what we call flaming. Of course, by seeing the flame here, a good number of you can already reconcile what I'm trying to say. So the typical object or instrument that will flame is our inoculation loop. When we're doing inoculation in the laboratory, this is an inoculation loop. So we always have to flame, always have to flame. And we do that under what? A Bunsen flame. This is a Bunsen burner flame here. So we flame to red hot. It must be red hot. And when it is red hot, we are sure of sterilization, 100% sure that we have attained sterilization. Good. Incineration is another method of hot air heating method. But the difference is that it is when you no longer need the object. Okay, incineration, I want to refer to the local word burning. Okay, you burn in a furnace. So remember that after burning, there's no other good stuff that come out of it except ash, which has no use for us. So if you have materials that you no longer have use for, and you feel that they can contaminate other materials or they can be of danger to the environment, the best thing to do with it is to incinerate. But the method should be very well coordinated because the gases that are released in the course of incineration, most of them are toxic to the environment. So it should be a very coordinated method. So let's move a little further. Moist heat sterilization. Remember, we said moist heat is another option, and we had boiling, steaming, and autoclaving as examples of moist heat sterilization. But let's start by appreciating that the procedure, the principle under which moistening works is by coagulating protons in the organisms. So moist heat will coagulate protons and make them difficult to function normally. The temperature at which moist heat is applied differentiates the different methods of moist heating that are used, but most of the methods will only attain disinfection, except as I'm going to indicate. So first, pasteurization. Pasteurization could be improved through an inspissator to attain sterilization, but the normal application of pasteurization ends at disinfection, ends at killing vegetative cells and not spores. But if we use an inspissator, as I'm going to explain shortly, we can attain sterilization. Boiling. Remember, boiling under atmospheric temperature can only get to temperatures as under atmospheric pressure can only get to temperatures as high as 100 degrees. At 100 degrees, even with a long time included, spores are unable to be destroyed. So spores are still very intact, especially endospores. So we cannot attain sterilization by boiling at 100 degrees Celsius. We can only attain disinfection. Now, to attain sterilization, we may use steam under atmospheric pressure. The cock or anus steamer is a method, but the most common method that we use in the laboratory to attain sterilization by moist heating is by autoclaving. By autoclaving, as I'm going to explain shortly, we use steam under pressure. So pasteurization has different types of temperatures and time intervals. There's what we call Holder method, and there's what we call rapid cooling method or the flash method. The Holder method applies steam at 30 degrees Celsius for 30 minutes, while the flash process applies steams at 72 degrees Celsius for 15 to 20 seconds. So you see that for the flash process, we have a higher temperature, but a shorter time interval. For the Holder method, we have a lower temperature, but a longer time interval. So what's the difference here? It depends on the items to be disinfected. Some items will not be able to stand temperatures of 72 degrees Celsius, while some are able to withstand only 72 degrees Celsius. So that's what we are left with, and we have to now look at these options. But note that none of these methods can attain sterilization. All these two methods can only achieve disinfection, can only kill vegetative cells. We can use a water bath as another method. A water bath can also be adjusted to get a higher temperature or a shorter temperature, or a lower temperature, sorry. And depending on the temperature used, we can either attain disinfection or sterilization. So a hot water bath applied at 60 degrees is usually used for 1 hour to sterilize vaccines. So when we prepare vaccines that are going to be used for administration or for injection of humans, we want those vaccines to be sterilized. And remember that vaccines most of the time will contain living organisms or proteins. So at higher temperatures, the organism will be killed. At higher temperatures, the proteins will be denatured. So how do we preserve our vaccines, but at the same time sterilize them? So the only way to do that is by using a water bath. Certain fruit and other biological components can also be sterilized using a water bath. Now, an inspissator is a method I said I was going to describe a little further. Inspisation is a hot air sterilization method, hot steam sterilization method that can achieve complete sterilization, that can kill spores successfully. How does that work? You introduce your sample into an inspissator. An inspissator is a special designed object, as we just saw earlier. This is an inspissator. So it's a system that has already been designed for this purpose. So you introduce a sample into an inspissator and you heat for half an hour at 80 to 85 degrees Celsius. After you heat, you allow the sample to aerate. So you expose the sample to oxygen. And then you do it again the second day and repeat it the third day. It is believed that by exposing the sample for aeration, you are able to stimulate generation of spores to vegetative cells. So all spores that were present will germinate. All spores that were present will germinate into vegetative cells, and then you are able to kill the spores alongside the vegetative cells, thereby attaining sterilization. I don't know. I just got a message for those on Skype that they are unable to see my screen. Is it for everybody or just for some people? Those on Skype, are you able to see my screen?
No, sir. Yes, sir.
Some are saying yes. So
yes, sir. Yes, sir.
If you are unable to see the screen, go log out and redial the call and rejoin the call again, you never will be able to capture the screen. Some students are saying it, which means I'm talking of those on Skype, please. Skype, is there anybody who can see the screen? The students on Skype, is there any student who can see my screen? I need a response to know that there are people alive there. The students on Skype, are you able to see my screen?
So I'm not seeing this.
You have not been seen throughout the lecture?
Yes, sir.
Oh, sorry about that. But it is being recorded and you have already shared the PowerPoint. So you could be following the PowerPoint you have, okay?
Oh, okay.
Yeah, I don't know how to adjust that, but the lecture is recorded and you could follow the PowerPoint that you have and everything will be fine. And I'll be willing to explain further after that. Good. Okay, in the meantime, we continue. For those on Zoom, know that the class will be restarting in less than 10 minutes. You know what to do. Just redial the link and you are back in class. The recording is still on and let's move on. Good. So with Inspiration, as I said, you can attend complete sterilization as you stimulate germination in the spores, and the spores will be able to, can be destroyed. Now we can also use boiling to disinfect. I already explained this earlier, but remember that boiling, no matter how long you use it, can only destroy vegetative cells. It hardly destroys endospores. Look at this sentence here. Endospores can survive up to 20 hours or more of boiling. So I'm not sure you can ever want to boil for more than 20 hours. So it is a waste of time. Go to another method as I'm going to be describing. So a steam sterilizer can also be used. It can be used at atmospheric pressure, which means that you cannot go above 100 degrees Celsius, and therefore you can only attain what? Disinfection. You can only attain disinfection. But we can also use a modified steam sterilization method called tyndallization. Tyndallization is similar to inspiration I just described. Here, you steam for about 20 minutes at 100 degrees Celsius. Remember that the temperature here is higher. It's 100 degrees Celsius. Under inspiration, we had a specially designed system working at 80 to 85 degrees Celsius. For tyndallization, we steam at 100 degrees Celsius for 20 minutes. We expose again, we aerate. We're exposed to oxygen. After 1 day, we steam again at 100 degrees Celsius for 20 minutes, expose again to oxygen. Then the third day, we steam for 100 at 100 degrees Celsius for 20 minutes. After these 3 days, just as with inspiration, we are assuming that all spores would have germinated and therefore destroyed by successive steaming. And we are sure of what? Sterilization. The most effective wet air sterilization method that is used by microbiologists is autoclaving. Autoclaving uses the principle of gas of Charles' law, which states that at constant volume, what happens? You can read Charles' law if you have forgotten. The relationship between temperature and pressure at constant volume. So at constant volume, temperature can go up, pressure can go up, and therefore we are able to attain 121 degrees Celsius within this earth. So autoclaving permits us to go above 100 degrees to usually 121 degrees, which is what we use. And at 121 degrees, we are able to attain sterilization. 121 degrees is able to kill spores, is able to kill vegetative cells, and is commonly used in the laboratory. Forget about the description of an autoclave. I just brought this image for you to see. Unfortunately, in the laboratory, we have a pressure pot, which still maintains atmospheric pressure. But I'm hoping that before the day of practicals, we might be able to get a hot air oven. We're able to get a hot air oven. Sorry, we're able to get an autoclave, but it's just hope. But I have an image here. This is an autoclave. You can see that pressure is maintained. As it builds up, pressure is going to build up when heating is going on. And since the volume is constant, pressure will go up, temperature will go up at constant volume, again, referred to Charles' law under the gas laws. So, as I said, forget about the description, the detailed description of the methods. I'm more interested in you understanding how this method attains sterilization or whether a method attains sterilization or disinfection. That's the more important issue I want you to take home here. After the break, after the restart of the lecture, I'll move to chemical agents of sterilization, which will also extend us to mechanical removal. See you shortly for those on Zoom, but for those on Skype, the lecture will continue back in 1 minute. Skype lecture is a continuous recording. There will be no breakage. I can only press it